we got to a point where we did synthetic division. I'm looking at it. We divided by 2. We got some numbers, but eventually we got f of x equals, what do we have? We did L, but I'll use x. So I knew x minus 2, because that's what we divided by. And we were left with x squared plus 3x plus 6. And just like on the old problem, like the one we just did, I stopped it because I knew 2 was a 0, and I could just plug it in, right? Well, if the problem had been find all zeros, we would have kept going, right? We would have tried to factor, or we actually probably would have used quadratic, I think, on this one, and I'll show it later. Basically, we're going to go from here now and say, no longer are we just going to say find all real zeros or anything. My objective is to be able to find all zeros.
Including K1.
Oh, I'll get there. Hold on. So find all zeros, real and unreal. Okay, that's one of our objectives. The other one is you're being recorded now. So you know I have cameras too. Record cameras. Find all zeros. You need to be able to determine the number of solutions for a polynomial. And you're going to be able to do that. You need to determine the number of solutions for a polynomial. You're going to be able to tell me how many solutions there are just by looking at a polynomial by the time we're done. Okay? And then the third thing we're going to do today, we're going to actually write functions when we are given zeros. So up until today, we have been given a function and a zero, or sometimes, actually, as we just did, not any zeros, right? No factors, no zeros. It's a function, and they go, hey, find all the factors, find all the zeros. We're flipping. They're going to give us zeros, some of them, maybe not all of them, and we're going to use that and figure out the entire function. Okay, you're going to write out the polynomial. So we're just flipping the process there. We've been factoring. What's the opposite of factoring? Multiplying, FOILing, distributing. We'll do a lot of it, right? Some of both. We'll use the big box method, all of that. So if you want an essential question, how do I find all zeros? And write out functions. Using zeros. The fundamental theorem of algebra. Write out polynomials. The fundamental theorem of algebra. Goodness, that's loud. So you've gotten all the way to algebra until now without knowing the fundamental theorem. How about that? So if a function, guys, it's way too much talking. If a function is a polynomial of degree n, degree being what, the highest exponent, right? So if it has an exponent n, and n is greater than 0, as long as it's bigger than 0, then that equation has exactly n solutions. Okay? The next part says if the solution is repeated twice, that's 2 solutions. If the solution is repeated 3 times, how many solutions can you get?
3.
3. How about 4 times?
4.
4 solutions. This is big fancy math talk for saying, if I have an equation, f of x, and if it goes to x to the 5th, and then anything else follows, how many solutions are there to that polynomial? There are 5 solutions. Okay? Because it is raised to the 5th power. Now, some of those solutions might duplicate. For instance, let's say I have something that has 3 solutions, so x to the 3rd is the highest degree, and I'm just making up factors. Let's say it factors out to, what did she use? Oh, I like that. X plus 2, x minus 3, and x minus 3. That is still 3 solutions. if you did the quadratic formula and you got something like 2 and plus or minus 4, you know, doing all the square roots, you're always left with a plus or minus. That is 3 solutions. Okay? So, just to make sure we're good, how many zeros does the function x to the 4th, and it doesn't matter what else I say, how many zeros does that have? 4. Oh, how many does it have? How many real solutions does it have if it has 2 complex solutions? 2. 2, because it has 4 total. 4 total solutions, okay? Minus 2 complex, leaving me with 2 real. I am 2 real.
And then you know that one was 4 because there's 4
Because it's-
numbers?
Oh, shoot. No, I'm sorry. It has 3 total.
That's what I thought.
Yeah, I know. I was looking at the wrong one. I'm sorry, guys. It only has 1 real. I was up here still. Sorry.
So why do you do that?
Why do you do what?
Like why if it's complex?
What's a complex number?
Okay. A number that goes on for a really long time.
Try again. Notice what it's, so how many real solutions, so real meaning it doesn't contain what?
All the way up to 10.
It doesn't contain I, doesn't contain imaginary, so what do you think complex has? I, imaginary. So if I'm going to apply the fundamental theorem of algebra to find all zeros, alright, go back to the, remember up here, where did I start with? X squared plus 3x plus 6. So, if I want to find all the zeros, I already knew I had, what, x minus 2? This is the pyramid again. Can't factor it, so I need to plug in quadratic formula. So, a, b, and c. X equals negative b, what's negative 3, plus or minus square root, what's b squared? 9 minus 4 times a is 1. I'm not even going to write it. What is c? 1, so I'm not even going to write it, so just 9 minus 4. Yeah. Oh, c is 6, sorry.
Yeah.
Okay.
I don't work by 1.
And 2a is 2 times 1, which is 2. It's my fault. So x equals negative 3 plus or minus, what's 4 times 6? 24. 9 minus 24.
You should have it as a test question.
Yeah, that was hard.
Negative 15, right, over 2. So immediately, square root of negative 15, what is that going to become? I radical 15. So x equals negative 3 plus or minus I root 15 over 2. Is that answer real?
You better believe it.
No, it's complex. It's a complex number. The other way of writing this, remember complex numbers are a plus bi. Your a is negative 3 over 2 plus or minus I root 15 over 2, right? You wanted to break that. That's how your book does it. Your book always writes complex numbers as a plus bi. It won't leave it like this. I'm okay if you leave it like that. Just know that I'm just copying answers out of a book. A lot of times for homework and stuff, I'm not going to take off for that. Right? That's good. On a quiz where I don't have a book to go off and I'm doing the key, I will leave it like that. My instinct isn't to change it to a complex number. So, steps for finding all zeros. Now that we're doing all of them, we're not just stopping when we get to imaginary. We have not factored much in the last couple. We factored while we were solving for zeros, but we've always done it after division, right? We're going to bring that back. Here's the deal. When you are solving for zeros, listen up, guys, because this is going to throw some people. When you're solving for zeros or factors, okay, you can always divide. You can always do long division. Sometimes you can do synthetic division. Sometimes before you do either of those, you can also factor, either by grouping or AC. So if I have 3 terms, and I can factor, I'm going to use AC method, right? If I have 4 terms, what am I going to do? Remember
Factor by grouping.
Grouping, yeah, there's grouping, boxing, however you want to call it. I always call it grouping. So factor by grouping. If you can factor before you divide, that's going to save you some time. You'll see it in a minute. We'll factor first to find some zeros, and that's great. If you can't do that, you try, you look at it for a while, you go through and you do P over Q, right? Find all your possible ones, and you guess and check, and use your graphing calculator until you get a remainder of 0, and then you keep factoring, right? You just factor down. Okay? You go away. So, this is the same problem we've done with, right? Makes easy now. It's really done. Find all zeros of the polynomial functions. So, if I was doing this, I don't have a 0 or a factor given to me. So, what would traditionally be my first step? P over Q. Well, P over Q. But some people are saying, well, factor this. Well, we can try. It's got 4 terms. And like I said, if you can factor ahead of time, save yourself the synthetic division. So I can definitely pull something out of here.
X squared.
Yeah, an x squared, leaving me with what?
X plus 1.
X plus 1. Do you already see it? What am I going to pull out of here? 4, leaving me x plus 1. That's beautiful.
Could we have been doing this yesterday?
On some of them, not all of them. So I wasn't like hiding this from you. So some of them. Actually, no, most of them you couldn't factor. I lied. So, all right, this is actually way easy now. What are my factors?
X plus 1, X squared plus
X plus 1. So what's weird about this is how many solutions should I have?
3.
3. So I know that one of my zeros is what?
1.
Negative 1.
Negative 1.
So then let's solve for this. X squared plus 4 equals 0. X squared equals negative 4.
Plus or minus 4.
It's going to have an I in
It's
it.
going to have an I. What's the square root of negative 4?
And the
2i, and since I square rooted, plus or minus.
Does that mean there's only one real answer?
There's only one real answer, but this asks for all zeros. Did I lose anybody there? We good? I know I might be a little unfamiliar. Just, we're not going to do anything so crazy with it, so they're not asking me to
I
graph.
thought you were saying you're.
We're not doing anything crazy with it. You might want to review just super basic functions with I, like multiplying and dividing and squaring. We'll do a little bit of that just as part of notes, but you may want to watch. Cool. What did I not do? I didn't find the answer.
You wouldn't accept that.
I would not. I'd give you a good, I like to give points. So you're always better off writing something on your quizzes and tests and homework. So I try to reward partial credit. Like, I want to give you points. But if you don't box your answer, I can't give you full credit. Alright, so the next one. 4 terms. So what do I probably want to try first?
Factor by grouping.
Factor by grouping. What can I pull out of this first guy?
X squared.
I'm pulling x squared. I could also pull out, I guess, just an x if I wanted. I'm just looking and thinking, well, I may want to. That leaves me with x plus 7. There's no way I'm getting a 7 out of 9 or anything like that. Anybody got any ideas? I can pull a 3. That would leave me with 3 times 5 plus 3, or x plus 3. Sorry. I'm not going to get x plus 7. Because that's what I want, right? I want a number, an x plus 7, not going to happen. So we tried. I would say, guys, give yourself 30 seconds on each problem to see, maybe a minute, be like, can I factor this? And if you don't get it by then, just keep moving on. Yeah. No, it's recording. Say hello.
Hello.
Right. So I can't factor by grouping, so what do I have to do?
The PQ.
P over Q. We're going to have to synthetically divide. So I'm going to do P over Q. What's nice about P over Q here?
It's only 9 and a 1.
It's over 1. So P over Q plus or minus, and I'm not going to write it over 1. because I know it's over 1. My leading coefficient is 1. So factors of 9,
139.
1, 3, and 9. Plus and minus, right? What do you want to try?
3.
You want to mix it up and do 3?
Yeah.
Alright,
Well,
let's
I
mix
mean,
it up.
last
3 or negative 3?
let's go negative. I'm lucky. Negative.
Positive.
11.
I heard positive was first. We'll do positive. So am I in standard form and I'm in order, right? 1, 7, 15. You think we'll get through this without incident this time? 3, 10, 30, 45. Not going to work, right? I am pretty sure it's negative 3. 1,
That's what I said.
negative 3, 4, negative 12, 3, negative 9. Okay, so what do I know one of my factors is?
Positive 3.
X plus 3.
Yeah, that's what I was saying.
What's the other factor?
1x squared plus 4x plus 3.
And I think that's going to factor really nice, isn't it?
Beautiful.
What do you think?
3 and 1.
So the weird thing about that, x plus 3 shows up twice, right? So for zeros, you can write a couple of things. You can write negative 1, negative 3, negative 3. And I'm okay with that. So writing it twice just to show me it shows up twice. You need to do something. This is called when something has more than, when a solution shows up more than once, like this, when negative 3 is a 0 2 times. That means that my zeros are negative 1 and negative 3 with a multiplicity of 2, which is a super fun word, multiplicity. So you can also write negative 1, negative 3, multiplicity of 2. If it showed up 3 times, it would be a multiplicity of 3. Don't write negative 3 times 2. That's negative 6, and that's wrong.
Charlie has a question.
Yes. Yes.
That's a good question. Yes,
So, you'll miss the complex conjugates theorem. The complex conjugates theorem states if f is a polynomial function, so if it has real coefficients, meaning no I in there, no imaginary numbers, okay, so if the coefficients of the function are real, and then you break it down, and if you have a plus bi as a 0 of f, so one of your zeros has an I in it, check this out, a minus bi is also a 0. So that's kind of nice. Let's save you some math. If you know that one of your complex numbers, the opposite of it, not the reciprocal, or not even really the opposite, but a minus the complex number is also a 0. You don't even have to do math. You just change the sign up, right? Irrational conjugates theorem. If f is a polynomial function and it has rational coefficients, take a stab at this. If a plus the square root of b is a 0, what do you also think is a 0?
A minus.
A minus root b.
That's a square root sign. That one's kind of obvious, I guess, for sure.
Is that confusing anybody? If you see it in action, it might help. Here. Remember your factor theorem. This is going to help you, right? If x minus a number is a factor, then x equals is a 0. That means that number is a 0. Okay? So remember that. So
Wait, that says x to the other. That says x equals.
yeah, sort of.
I didn't.
So remember, my one of my objectives is write functions given zeros. Write a polynomial. Listen up. Write a polynomial function f of the least degree possible, smallest degree I can, that has rational coefficients, a leading coefficient of 1. So that's kind of nice. It's going to tell me what my leading coefficient is. All right, and the given zeros. So how many zeros do I have here? There's a comma here, just so you know. So 3 and 2 plus root 5. How many zeros am I getting? 2. How many do I actually know?
1. I don't know. That's my guess.
2 plus, if 2 plus root 5, yeah, if 2 plus root 5 is a 0, what is also a 0? 2 minus root 5. Remember, if a plus the square root, if a plus root b is a 0, a minus root b is 2. Like I say, it's not even math, you just know that. That's just the theorem, right? So I actually have 3 zeros. So what degree is this polynomial?
To the just x.
To the third, right? 3 zeros. So x to the third. So if I know that these are zeros, what can I change them to? Factors, right? So what are my 3 factors? The first one's easy. X minus 3, right? So x minus 3 is my first one. Here's where it gets a little tough. Watch. This is going to be the same for complex numbers, the same for your irrational zeros, all of it, right? It's still x minus, and then the whole thing, 2 plus root 5. Because 2 plus root 5 is my 0. So x minus 2 root 5 plus root 5 is my factor. Yeah, we'll distribute, okay? So my other one is x minus 2 minus root 5. Everyone see that? I got 1, 2, 3 zeros. They're all just x minus my 0.
Yes.
Alright, so what's left?
If solved earlier.
I don't want to solve what the instructions are to write a polynomial. I want to write, so I'm going to wind up distributing, right? I'm going to FOIL and distribute, use the box. We'll do the box. First thing I want to do, though, I probably want to distribute this negative sign around, right? So let's rewrite this as f of x equals x minus 3, x minus 2 minus root 5, okay? And then let's distribute it here, x minus 2 plus root 5. All I did was distribute that negative sign inside this parentheses.
Do you change it? Oh.
Yeah, I did. Minus and negative is adding, right? So box method, we could start here and distribute. I think it's easier to just take this whole chunk and do a one big box and then distribute that x minus 3. So, put on a box here. I've got x, negative 2, and negative root 5. Right, that's that one. And then the one on the right, x, negative 2, and positive root 5. This looking familiar, guys?
Is that old tooth paint?
No idea what you're talking about.
I don't either.
So you don't have to do a box. I usually don't do a box. I just work across and I just distribute the x around there, and then I'll do the 2, and I'll just write it in one big line and cross things out. The box, I'll admit, is pretty nice. And I've started doing it more often, especially when I'm doing 3, when I'm doing 2 binomials, or like this. I won't do it when I get to here, because it's just 2 steps and it's kind of silly to draw a whole box. But here the box is pretty nice. So negative 2x. Yes, it should. Negative 2 times negative 2 is 4, right? And root 5 times root 5,
Root 5 squared.
which is just which is the square root of what? 25, which is 5, but negative, right? Whole thing was negative. Cool, so it's not, this is why I like the box method. It's really easy to see what cancels. Those are going to cancel, right? These are going to cancel. Nothing else cancels. So then I'm going to rewrite this as f of x. I still got this x minus 3 hanging out.
Wait, do those cancel with us negative x root 5 and x root 5? That's the same thing.
Yeah, but they cancel.
Oh, I see. Never mind. Weird.
All right. Anyways, x squared. So I only have 1x squared. I've got a minus 4x. What's that become? Minus 1? 5 and then I have negative 5 and 4, right? Have I lost anyone there? Are we good? We've done this before. It was a while ago. When I say we, it's not me because I wasn't here. So you've done it. Oh, was I?
Yes.
Oh, hey. Oh, yeah, that's right. That's pretty cool. So, what's left? I'm not done yet because I need to write out this polynomial. There's only one more step. What is it? I just want, no, I'm reversing a factor. I just need to distribute one more time. Okay, let's do it one more time. F of x equals, and this is where I just do the lines. If you want to do another box, totally fine. But I'm going to do lines. X times x squared, x cubed, x times negative 4x, negative 4x squared, and x times negative 1. Right, then the 3. Negative 3x squared, positive 12x, and less 3, right?
3x cubed or squared?
Yeah, it's squared. And then we just got to do one last step. Combine like terms f of x. I've only got 1x cubed. And stop right there and see if you follow directions. A leading coefficient of 1. Do we have that? Do we have the leading coefficient of 1?
Yes.
Do we have the least degree? How do I know if I have the least degree? Well, how many zeros did I have? Gave me 2, but I knew 3. And so if I know 3 zeros, what's the highest degree it could be? 3.
And it's x cubed.
And it's x cubed. Beautiful. All right, so squared terms, I have 2, negative 7x squared, right? I have a positive 12 and a negative 1, so plus 11x. And just a plus 3, right? Is that it? It's nothing new, guys. We're just... It really isn't that new.
It's just a lot of
They're long problems, but at the end, man, is it pretty good.
no.
Yeah,
Like
great.
I just went
I think it's awesome. Like even guys, even now, when we like doing this whole thing, like doing 41 up on the board and then clicking back on sphere on the document cam and being like, yeah, I got that right.
No, we do not have the same emotion.
Oh, yeah.
I feel like
You
I'm
guys
doing
don't
right.
Seriously. All right. All right, let's do this last one.
I like it when
Hey, same problem, guys, same problem. I have zeros, and I need to expand, make the least coefficient of 1, smallest degree possible, expand the whole thing, right? So one of my zeros is what? 2. The other 0 is, and this,
Complex.
yeah, it's complex, so there's a comma there. It's negative 2 minus 5i. Do I know any other zeros?
Yes.
Complex conjugates there, but a plus bi is a 0, a minus bi is also a 0. So what's the 0 I'm missing?
A minus B.
Right, a is negative 2, so plus 5i. Everybody got that? Don't change the a. The a doesn't change. Don't change it to positive 2 plus 5i. A is still negative 2. So all you're doing is changing the sign in front of your bi. Cool. Negative
Why is
2
it called a B?
is just a number. Why do they use x? Cool.
First curve.
No, hey, yeah, the quiz is not 5-7, so you're not going to expand out. It's only 5-5 and 5-6.
You should curve the test.
No. Well, maybe a test. Not a quiz.
Yeah, test.
We'll see. Maybe. All right, so I've got 3 zeros. I can't get any of those zeros from this? No, not a trick question. You can't. So I got 3 zeros. So what should my highest power be? 3. Cool. So let's write out my factors. F of x equals, the easy one that I know,
2.
x minus 2. Then x minus, and then, oh, guys, seriously, always put these in parentheses. Negative 2 minus 5i. Okay? And x minus what?
Negative 2
Plus
plus 5.
plus 5i.
Plus 5.
Would be awful if you just distribute and then not that.
No, I'm okay with that. When you're right, that's fine. All right, let's distribute these negative signs. Minus 2.
What is the square root of I? Is it negative 1?
Square root of I?
Or squared I?
Yes, because we'll get to that. Don't worry. Plus 2 plus 5i. X plus 2 minus 5. Alright, let's set up a box.
Can we do the other thing?
What, the not a box?
Yeah, another box.
Honestly, okay, with eyes, the box is more useful than that. I mean, we can not do it, but
I just want to go over one. Because I don't.
the box or without it.
But you gotta.
Alright, we can try it. Alright, so,
I want to use the box.
I know you do.
Okay, fine. Use the
I
box.
honestly, no, I really think we should use the box. Because you're not just talking about 3 times 3, you're also throwing these eyes in there. And I would use the box. I would absolutely encourage it. So x,
Don't use the box. You cannot use the box.
x2, 5i. What automatically goes? It's a smart board. X to negative 5i. Alright, x squared to x. I don't write 5ix because it looks like 6. So I write x 5i because my 5's are weird.
Really?
I mean, seriously.
I was kidding.
Oh,
It's just 6.
It's like you wrote up.
2 times 5i.
10I.
10i. Good. Don't get all complicated. 10i. Negative x 5i. Negative 10i. And then negative 5i times 5i.
I will give you 25.
Well, negative 25. And then I squared, right? What is I squared?
25. Oh.
I squared
Negative
is
1.
negative 1, meaning what am I left with?
25.
Positive 25, right?
I seem to have 3 steps.
Alright, so what cancels? That and that, right? 10 and negative 10i.
Do those ones always cancel out? I guess that was a guess.
Yeah. Well, if you've got the plot, it depends where your positive and negatives are. I'm sure really smart people can see the patterns in positive and negatives and immediately cancel without drawing a box. But, and that's great. So, I still know x minus 2. So f of x equals x minus 2. And let's write this guy out. I've got an x squared, right? 4x plus 29. Cool. Alright, so let's distribute. I'm not going to do the box. I'm just going to draw lines, right? F of x equals... Oh, I don't need this one.
X cubed.
So, x cubed
4x squared.
plus 4x squared
29x.
plus 29x
Minus 4x.
minus 2x squared
Minus 8x. Minus, let's go with
58.
58. Oh.
Did I lose anybody? Like I said, you can draw, guys, you can please draw a box. if it helps you, I have no problem, as long as things aren't getting crazy messy and, everything all over each other, so. Alright, so finish it up, f of x cubed plus 2x squared, good, plus 21x. I need a calculator for this last one. No, that's fine. It's not even mine. All right.
That's Danny Jones.
Ladies and gentlemen, you're gonna want to see this last part. From 1890 to 2000, I could not show you, and you could not know how to do this on your homework. From 1890 to 2000, the American Indian, Eskimo, and Aleut population P, in thousands, can be modeled by the function, look at that big scary number. Goodness. Are you gonna synthetically divide any of that, do P over Q? No, you're gonna use a calculator, okay?
How many calculators are in 720?
I don't know, I don't want to know. So, hold on.
Less than 720.
So what I'm gonna do, guys, I can't just plug this straight in my calculator. I can't just plug this straight in. What I need to do is I want, 722 equals, and then this whole mess, right? I need to set this equal to 0. Then I can plug that into the calculator. The new equation is set equal to 0. And what do you think I'm going to use the calculator to look for on my graph?
X-intercept.
X-intercepts. That's what I've been doing the whole time, right? I've been setting things equal to 0, and then finding zeros, or x-intercepts, or solutions, right, or roots. You're doing the same thing that your calculator is going to do it. You guys probably know where in your calculator how to calculate zeros, right? Where is it? No? I'll show you. So this actually becomes, and I'll just type it.
Don't you select one that says X-intercept? I mean, intersect.
So I want, oh, this is so far away, 0.0035, and I want x to the third, right? Okay. Minus 0.235 x squared plus 4.87 x, and then it was plus 243, but 243 minus 722 is what? Negative 479. All right. So if I graph that, mine looks different than yours. I adjusted my window. Guys, you've got to mess around with your window. Ultimately, you know you're not looking for negative population, right? And you're not looking for negative years.
Wait, where did you
So what quadrant have I restricted myself to?
The top right.
Quadrant 1, right? So yes, I mean top right, that's fine. So I put a minimum of 0 because I'm not interested in negative x's. I'm not interested in negative y's, so I put a 0 there. And I just chose 300. You can go higher, keep going until you can see everything. Because ultimately, what I want to do, guys, the calc, which is second trace. Which one do you think I want?
The one that says intersect.
Intersect is where two functions intersect.
You want to do 0?
0, right? So if I choose 0, it says left bound. The left bound is to the left of where I think the x-intercept is. And I can see, looking at this thing, the I can see it, right? So if I work my way down, keep going down until my guy shows up here. Ah, there it is. Okay, so there he is. So if I go into a negative y, I'll be to the left, won't I?
Sure.
So negative 84. That should be good. So I find the left bound. I hit enter. It wants a right bound. Okay, so a right bound will be in the positive y. So 306 should certainly do it. You can't see my thing. There it is. We'll go there. 191. And then it just wants a guess. just guess somewhere in the middle of them. There's y equals 88. Negative 3 is pretty close to 0, right? 73.5 and some
Not
change.
put the 243 in there.
No, it's got to be set equal to 0. Wait, did you say did I not put 243? I subtracted 722 from 243.
So what was your equation that you put in for y?
The y, it's the exact same, right? But look up there. 722, so if I subtract 722 from each side, I get 0 equals. And everything stays the same, but instead of plus 243, I have minus 479. So 73. So what does that mean, guys, my answer of 73? So I got x equals 73. That's my 0. That's great. But 73 what? It's actually 73.5. What is that? The number of years, guys, x or t, right, is the number of years since 1890. I want to know what year we reached 722,000. So what is the only thing I'm missing? Tell me what year. I don't want the year 73. I want 1890 plus 73.5. And I'm not interested in the 0.5. It doesn't say, hey, in what month did it happen. It just wants the year, so I'm just going to drop that. 1962.
Wait, is that real?
Oh, I don't know. It might be.
Wait, 73.
It says 73.5, but I'm not interested in 0.5. I just want to know what year did they reach 73.5. Guys, so listen up. Homework is just 5.7, right? Is that what we're on? Yeah. Give me, pass forward your homework, 5.5 and all 5.6. Pass your homework up. Homework is all 5.7, unchanged. You have a quiz tomorrow. Well, you might as well wait. Well, I'm just saying, you only got 2 minutes. The equation. Real quick. Writing your homework on the board. Hopefully we already have it though.
It feels like Tiger Story.
Tiger Shark.
Okay, try it like yours.
Who are you?
That's fine.
What's he doing this for?
Sorry,
No, you're fine.
zoom out.
Picking up a million things.
Let's see. All right. Not enough hours in the day.
What's up, Harrison? How you doing?
Hey, Bob.
All right.
That just so disappointed. I mean, I spent so many hours on it. It doesn't even matter. I mean, I know it's not her fault, but she really should have tried to control
You basically. Ooh.
I was like, really bad. I mean, it was the weekend, it was spring break, I'm calling like all of our assistant principals, I'm calling the social worker,